Hey everybody, and welcome to lesson 6, activity Geocentric Orbit. I don't have any lo-fi hip-hop playing in the background this time. I'm outside on my back porch. It's a beautiful day, so hopefully you get a nice little chiming of wind chimes in the background. You can imagine you're outside on a beautiful day and not inside at your computer slaving away at a summer class. Props to you all, really, for all the hard work you're putting in this semester. I've been very impressed. I know it's tough. I know it's tough distance learning this material. We've never done it before, but you all are really doing an excellent job. So thank you so much. Now, for this activity, if you follow the directions, it's not that hard, and really just you got to keep in mind some of the basic things like order of operations, integer division, and how that works. But the biggest thing really is to just follow the directions very specifically, and again, doing it in following the to-dos and the instructions here in the specification section. So first, let's go ahead and get our project set up. I've already got activity 6 created in Eclipse. I am, however, going to save these two files we have here, orbit.java and earth.png. So again, when it opens like this in a browser page, I like to right-click, Save Page As, and save it as a .java file in my downloads. And notice again, it's getting saved as a plain text document, because that's what source code is. It's just plain text document with a .java file at the end. And then we've got this nice little image of the Earth, so I'm going to save image as earth.png, and I'm going to save that in my downloads as well. And I'm going to double check because it looked like it didn't really save that well. Let's double check this. Looks like it is a PNG image in my little file explorer here. It's going to take like five minutes to pop up, but there we go. Cool. So let's go ahead and import these into our activity 6 assignment here. So I'm going to right click, go to import. General, we're importing from the file system, so I'm going to select that option. Select the directory we're going to choose from. I am choosing from downloads, so all I have to do is make sure I'm in the downloads folder here and hit open, and then I'm going to see all my downloaded files. So let's select earth.png and orbit.java, hit finish, and we're good to go. So I'm going to go ahead and open up orbit.java, zoom out here a little bit for you. And so let's go back to our assignment directions here real quick. When you run the program, you should see the Earth in the center of frame, modify orbit.java to do the following, and then specifications. Direction number 1, define an orbit radius variable, assign it the minimum of 1/3 the width and 1/3 the height of the screen. So whoa, jumps right into it, doesn't even tell you where. That's because we would normally be doing this in person, and the place you're going to do all your work, just like these last few image-based activities that pop up a window. And you see there's our earth.png, so that did get imported successfully, so you can exit out. We are going to be doing all of our work in this paint component method again, because we're going to be drawing an object around the screen. Now, this object is going to be moving, it's going to be pretty cool. So let's look at what we're working with so far, because we are hopefully a little bit more familiar with this now that we have the minifig activity under our belts, as well as hopefully at least part of Project 0. So we've got width and height, which are going to be the width and height of the screen. So again, those are going to change as the screen gets resized to be the width in pixels of our screen and the height. Then we've got the Earth radius has already been decided for us, and Earth X and Earth Y positions. Now, one thing to be aware of is that on step 2 it does say the Earth X and Earth Y variables define the middle of the Earth, not the top left corner. So the instructors did this for you and gave you this variable set up that way just to simplify your orbit calculations a little bit. But let's go ahead on step 1 and define orbit radius variable. Now again, we should be reading the to-dos in the assignment and the to-dos in our assignment the to-dos in the code, and then the to-dos in the steps on the assignment. So to-do, define the orbit radius. And the orbit radius is going to be minimum of 1/3 the width and 1/3 the height of the screen. Use math.min and the provided width and height variables. So what does math.min do? Let's go ahead and look at the math documentation. So whenever I hear about a method in the math class that I don't know what it does, I just go and I look for it in the math documentation. Again, if you just Google Java math and go to the first oracle.com reference, it takes you here. So I'm looking in the methods alphabetically for the min method. So ILM. And looks like there's two or three. There's one that takes in ints and returns ints, one for floats and one for doubles. We are going to be using the one, and long. We are going to be using the one that does ints. And what it does is that you pass it an integer A and an integer B, and it's just going to return to you the smaller of the two values you passed it. So our orbit radius is just going to be the minimum of whatever 1/3 or 1/3 of the width or 1/3 of the height. So this is going to be called int orbit radius equals math.min. Again, this is a static method, so we call it using the name of the math class. We didn't have to create an object to do it. And it's going to be the min of the width divided by 3 and the height divided by 3. And that with a semicolon. So let's go and double check to make sure that's what we were really supposed to do. So we define our orbit radius variable. Awesome. So step 2, we're going to use this radius to draw the orbit around the Earth. And this is the important thing to know. The given Earth X and Earth Y variables define the middle of the Earth, not the top left corner. But, of course, our orbit is going to get drawn from the top left corner. So how are we supposed to do that? Well, let's talk about this a little bit. Sorry for the awkward cut there. I did have to figure out how to draw a circle in Autodesk Sketchbook. Whoa there. So, now that I know, let's go ahead and draw this bad boy. So, here is our Earth. I believe I can drag this guy around. There we go. So here is our Earth. And what we're doing is we are going to draw an orbit around it. So I'm going to go ahead and switch back to my black pen here. Actually, let's do gray. And we're going to be drawing an orbit around our Earth. So imagine this is our orbit here. Whoa, I didn't mean to erase part of my Earth. Anyways, you get the idea. This is just about as good as I am at drawing on a whiteboard. So that's what we're going for. We're going to use the orbit radius we defined to draw the orbit around the Earth. But how are we going to draw this circle, this little dotted line circle that I've done here, when this circle is going to be drawn, in fact, from the upper left-hand corner. So it's going to be drawn somewhere up here. I am going to switch back to black. And this is going to be X and Y of our orbit. And I'm going to call it orbit X or orbit Y. Well, remember that Earth X and Earth Y are down here in the middle of Earth, so we can call that. Whoa, that's not going to cut it. Right there. We'll call this there we go. We'll call this Earth X, Earth Y right here. And so, really, Earth X and Earth Y is orbit radius away from the center of the Earth, because our orbit radius, that's how we're going to use it, is this distance right here. Trying to draw a dotted line for you. So that is orbit radius. Orbit radius right there. And so for orbit radius x, remember our x values still go, our x and y values still go this way. We're still drawing on a coordinate plane. So x, y. So remember, our x values are right here. So this is orbit x, and then our y value, this is orbit y distance right here. So your orbit x and orbit y are really just Earth x minus, because remember we're going in the negative x direction here. If we did Earth x minus orbit radius, we'd get here, and Earth x minus orbit y, we'd get here. Because remember, y goes down as you go up the screen, and x goes down as you go to the left side of the screen. And so our orbit radius is really just the distance from the center of the Earth to where our orbit gets drawn. And we can draw that circle by going Earth x minus orbit x, because remember our circle is going to get drawn from the upper left-hand corner, and Earth x minus orbit y. So let's go into the code and go ahead and do that. Because we are using this radius to draw our orbit around Earth now. So to draw orbit path. So now we're down here. So remember we're going to do G. And then what should we do to draw our orbit path? We used fill oval and fill rectangle before, but we're actually going to be using the draw oval method now. And for our x value, we are going to be using Earth x minus orbit radius, Earth y minus orbit radius now. And remember, this is going to be a circle around our Earth, so our width is just going to be orbit radius. And we'll see if that's correct. I don't know if I feel so good about that. Because remember, for the draw oval, draw rectangle, fill rectangle goes x, y, width, and height. And of course, the width and height of a circle are the same. So let's run it and see what happens here. Okay, it totally did not draw in the right place, although I do think it's x and y is kind of correct. But what's going on here? Well, remember, our variable name is orbit radius. And what's the difference between a radius and a diameter? You even got a little hint here. Well, this is the width and height of our oval, right? And so let's draw that again. The width and height of our oval is not quite correct. Now, it's actually almost looks like it needs to be about twice as big. Well, and that makes sense because, remember, radius is just half the diameter. We actually have to do orbit radius times 2 because, again, the width and height of a circle is its diameter. So let's try drawing this now. And boom, beautiful, perfect, and does it scale? Oh, baby. It does, in fact, scale. And that is a big thing on this activity, is your drawing has to scale. If it doesn't scale, you're not going to do well. So that's step 2, I believe. Let's go through and read it to make sure we did everything. Let's read the to-do. So the next one says define the radius of our object. Well, what's our object? Let's go and read the activity directions and find out. So step 3, to keep things simple to start, we will just draw a circle orbiting around the Earth. So the end game of this activity is to draw a little planet, basically, or a little moon orbiting our Earth. So to start, we're just going to draw a circle orbiting around the Earth. And we're going to define an object radius variable and assign it 1/5 of the Earth radius. So again, our radius we're going to end up using to create our width and height of our object. And our object radius is going to be 1/5 of the Earth radius. So let's define our, we'll use an int, object radius. And that's going to be Earth radius divided by 5. Easy enough. So now step 4 already. So we're cruising through these. We're just following the directions very carefully. Use trigonometric functions to calculate your object's x and y coordinates. Y is the vertical distance from Earth to our object, x is the horizontal distance from Earth to our object, and r is the radius of the orbit. So again, r is our orbit radius, right? And then to get the x position of our object, we just have to figure out this side of the triangle. And to get the y position of our object, we have to figure out what this side of the triangle is. So we're going to be using the math classes, cosine and sine functions, to figure out what our object's x and y position are. Because eventually, this is what we're going for, is we are going to be drawing a little object. Whoa, I keep drawing little dots everywhere. That is not what I intended. So we are going to be drawing a little object here, orbiting around the Earth. And again, this is orbit radius. Whoa, I didn't mean to do that. Still getting used to Sketchbook. Alright, so let's go back to the activity description. So we already have our object radius because we were just able to define it ourselves, but we do have to calculate the x and y positions. However, your activity actually gives you some, what I would call, pseudocode. So notice it's kind of in Java format. It kind of looks like it could be any programming language, but notice there's no data types. There's no semicolon. We're not using the math class to call our cosine and sine functions. This is what we call pseudocode, where it's code-like. It's enough to have you easily be able to type it up as Java code, but it really just gets the idea across. And this is the type of stuff you should be writing down in your notebooks when you're trying to figure out how you're going to attack a problem, say in a project or something like that. And so we just need to turn the pseudocode into actual Java code, and then after that we're going to draw our object using the object x position and object y position we calculated. Now what's this theta? We haven't really seen that yet, but if you go into your orbit code, we are in the paint component method, but if you read around, there are some comments about theta, particularly here where we add on to orbit theta. We add orbit d delta plus orbit theta. Now, the thing that's making your object orbit in this activity is actually this angle value, theta, right here. And it's our orbit theta. And notice, just like our x offset in our traffic animation starter code, we get orbit t delta, which is just a small value, added onto orbit theta every time we call paint component. And so what that ends up doing is it makes this angle here, created by just 0 degrees on your unit circle, or I guess 0 degrees would be up there. I kind of forget my algebra. But you've got this theta, right? It's this distance here. And as this angle gets bigger, the object orbits around the Earth. So notice as this radius, this angle right here, gets bigger, the object will move. And so, just like in your traffic animation, you have an x offset that changes. Here we have a theta that's changing, that's causing our object to orbit around the Earth. And that's why we can use our theta value and some trig functions to calculate where our object's x and y positions are. So let's go ahead. I'm actually going to take this code, and I don't want to copy it because copying Google Docs into Eclipse really messes some things up. It actually causes some of your character encodings to get messed up. So I don't recommend doing that. But let's say object x equals Earth x plus r times cosine theta. Let's just type that up really quick. And that's right here to calculate your x and y. So I'm going to put the type will be an int. Object x equals Earth x plus r times cosine theta. Alright, and that's just super basic. I believe that's what it was supposed to be. Earth x plus r times cosine theta. Object y is Earth y minus, and this minus is a big deal. A lot of folks forget it. R times sine theta. Earth y minus r times sine theta. So now that we got our pseudocode in here, Eclipse is angry at us, but we can fix that. And eventually we can get this turned into real Java code that's going to work for us. And so, first of all, let's take care of some of these errors. So r is obviously not just r. In our drawing, r is actually orbit radius. So let's change r to orbit radius. And theta is not a variable, it's actually orbit theta. Again, this is the angle, not to be confused with orbit t delta, which is the amount that we're adding on to orbit theta. So this is the actual angle between the object and 0 degrees that's going to cause it to move. It keeps increasing every time. And then cosine and sine are mad at us because, remember, these are static methods on the math class. So we have to call it with the name of the math class. And Eclipse is going to get mad at us because obviously we're saving these in ints because we're going to be using them in those draw methods. But it's saying it can't convert from a double to an int. So let's use our little quick fix here and add the cast. Now, the place where we do the cast is important. Notice that Eclipse puts the cast around the whole expression. And you want to do that. And you want to do the cast around the whole expression. You don't want to like cast math.cosine orbit theta to an int. Because what's going to happen when we cast math.cosine theta into an int? Well, the cosine and sine functions, I believe, if I remember correctly from math class, always return a value between 0 and 1. So if you cast that to an int, a decimal point to an int, it's just going to be 0. So it's important that we do all of our math, get as much precision as possible in our double value, and then cast it to an int. So what this allows us to do is does all our calculations and then just cuts the little decimal point off at the end. So that cast is how you do it around the whole expression is very important. And remember, if you're going to cast the whole expression, the result of the whole expression to an int, you need to put these parentheses around the whole expression. So let's go back to our code. So now that we've done our calculation, we're going to draw our object using object radius, object x, and object y. So we're almost done, folks. Draw your object as an oval with a random color. So first thing we need to do is get our color. So let's make a random color. I'm just going to call it C. New. Whoa, what happened here? And let's create a random object because we do need to. If we're going to use the methods in the random class, we do have to create a random object. And we'll do ran.next int, and we'll get past it 256. And we'll do that again and again to get our red, green, and blue values. Whoa. Alright, and now we've got a random color. We're ready to draw it. Remember, when we're working with the graphics class, it is like using a paintbrush. So we got to dip our paintbrush in the color we just created. So we're going to do g.setColor. We're going to pass it the color C that we created. And now we can finally do g.drawOval. And actually, we want to do fill oval. We want our object to be solid. And we're going to do object X, object Y. Width is going to be object radius. And then height again, object radius. So let's go ahead and try to draw this. Whoa! Okay. It looks like our object's being drawn correctly. Almost. It's changing colors. It's a random color. That's good. But it's jumping around like crazy. There's something wrong with how we're drawing our object here. Let's try to figure it out. So one thing I missed was this hint. It says the math sine and math cosine methods use radians for the parameter units. Orbit theta is in degrees. So we have to try using the math.2radians method to convert orbit theta from degrees to radians. So this will smooth out the orbit, because obviously that doesn't look too smooth right now. So luckily that's a quick fix. So we need to convert orbit theta to radians before we pass it in math.cosine. Now again, I could do, int radians equals orbit math.2radians orbit theta, but that just puts in an extra line that we don't really need. Again, you can do math inside of method parameters. So what I'm going to do is I'm just going to convert orbit theta to radians right here before I pass it in to math.sine and math.cosine. So notice this is inside the outer parentheses, so it is going to happen first. And if we're really going to talk about how these parentheses are evaluated, first we're going to convert orbit theta to radians. Then we're going to do our cosine calculation. Then this multiplication is going to happen. Then the addition. And then the cast to int. So now we're converting our value into radians correctly. Let's go ahead and draw our object. Okay. So we're doing a lot better. It's orbiting. It's a random color. But it's not quite following our orbit line. Now we want the center of our object to be along our orbit path. And notice how it's kind of following along the outside of it. But look more closely at it and think about how objects are drawn in Java graphics. Remember, our circles are drawn from the upper left-hand corner. That's why we had to get our orbit x and y. So our object is being drawn from the upper left-hand corner as well. And remember, with circles, it's drawn inside a bounding rectangle. So take a look and kind of follow it around, and imagine in the upper left-hand corner the bounding rectangle of our object. It's almost like the corner of that square is following along the orbit path perfectly. That's because it is. That's what our object x and y are. Our object x and y are centered around the orbit path, but our object, of course, is being drawn from the upper left-hand corner. So it doesn't quite look correct. We do have to correct this. We can't submit the assignment like this. So how are we going to go about it and correct it? This is a hard assignment, so don't worry if you have to follow around. This is probably the hardest activity of the semester, honestly, in terms of like what you have to think about and all the concepts you have to pull together. And it takes a long time in class, and I help you guys out a lot, so don't worry if you're struggling to follow along. So let's go up ahead, kind of draw a macro version of what's going on and how our object's being drawn, so maybe we can imagine how to fix it. So I'm going to go ahead and I'm actually going to clear out my drawing here because I think we're done with it. And so if this is our orbit right here, and I'm actually going to draw a circle again because that was kind of fun when we did that. Whoa. No, I want that back. That was sick. Cool. So this is how our object's currently being drawn. Is imagine there's an invisible square. So remember, this is the bounding rectangle of our circle. And inside of it, we have our object. I know it's a really poor object. And up here, right there, is our object X and our object Y. But we need object X to object Y to be at the center of our object, right there. So how can we move our object just a tad up over here on top of our orbit path? Well, let's take a good look back again at the activity instructions. And notice how our X and Y position, kind of like how we did with our Earth, are moved up and away from Earth. Notice that's kind of the same thing we have to do here. Because this is our object radius, right? And notice that would mean that our object X needs to be moved up by object radius, and our object Y needs to be moved up by object radius to move our square in this direction. So object X really needs to equal object X minus object radius to make it look correct. So let's try that out. Now again, this is really hard. It's hard to visualize, but we need to move our object up object radius diagonally. So to make that happen, we got to move its X by object radius and its Y by object radius to center it on our orbit path. So let's try that out. Now we could do the math here when we calculate object X and object Y. Or we could do it down here when we fill oval. I'm going to actually do it up here after our cast happens. I'm going to subtract object radius from it. And again, here when we calculate object Y. So let's try that again, see what happens. Uh-oh. Something's going on here. Now, why is our drawing still looking like this? Well, we went really in depth with our drawing here, and we figured out what we needed to do for our object. This is correct. We moved our object up correctly, but what we didn't do was we didn't actually draw our object correctly. Now, look what we used here for our width and height. Remember, radius is only half the width of a circle and half the height. We actually have to multiply this by 2 to get our diameter. And if we run this now, we'll see that our object draws correctly, it scales, it's orbiting. We are gold here, folks. So let's scroll through the to-dos and the activity directions and make sure that we are truly done. So that was our last step. We don't have to do step 7. You can if you want to. I'm not going to go over it in my video here. But let's scroll through the to-dos and the code as well. And yep, sure enough, there is one more to-do to do. Generate a random theta delta value from -10 to -20. So let's see, how are we going to figure out how to do that? So this is part of the activity I actually didn't prepare for. So I'm going to need your help. So one thing we can do, you don't have to do this, but there's really no point to have two random objects in our code, because remember, to generate a random number, we're going to need a random number generator. And ours is down here. So what I'm going to do is I'm actually going to cut this guy out. I'm going to paste him up here. So there's no reason that we can't define our random object up here in the instance variables of our class. Because now, notice, Java's happy down here. We can still see our random object. We'll talk about these and why we can move it up here in a future lesson. But we can also use it down here. So if we need to generate a random theta delta value from -10 to -20, remember, Nextint can only generate positive numbers. And so I always think when I'm going to generate a random delta value, I think, well, what's the highest number we need? We need to have up to and including 20. The lowest value, we need to have 10. And it needs to be from -10 to 20. So let's think about, how are we going to get the upper end? Well, how can we generate a number between 0 and 20? We need to do ran.nextint .20. So that's going to give us a random number from 0 to 20. But how are we going to get a value from -10 to 20? Well, I think to get -10, we're going to have to subtract 10 from the answer we get here. But what about 20? Now, we're always going to subtract 10. So if we get the biggest number we're going to get here, if we get 20, 20 minus 10 is only 10, so that's going to be the upper range of the numbers we can generate. Worst case scenario, we get 0, the lowest value, we get -10. So our lower end's taken care of, our higher end is not. But what if we put 30 in here instead? So we get, let's say we get 30. Well, we can't actually get 30, right? So maybe this needs to be 31. Because remember, it's going to be a random number from 0 to our boundary -1. So we put 31 in here. So let's say we get 30, the biggest number we could possibly get. 30 minus 10 is 20. Awesome. So our upper end is taken care of. Let's say we get 0, we get -10. That's the lowest possible number we get. So that's how we're going to get our range. So now we have a random number between 0 and 31 exclusive, so we're going to get 0 to 30. We subtract 10, so we've got both our upper and lower ends taken care of. And now we run it, and you can see that the speed of our object will change from run to run. And there you see it's a little bit faster. So that's activity 6 for y'all. I hope you enjoyed it. Please ask questions about this one. It is a hard one, so if you are wondering or you felt like you need me to go over anything again, drop by office hours, drop by TA hours, ask a question on Piazza or via email. I'm here for you. So everybody, catch you later. Happy coding.